Hello, we'll start with the total probability theorem and Bayes theorem. So, in our exercise 13.3, we do have the total probability theorem and the Bayes theorem. Okay, to understand that what it is, why these probability theorems, why we are studying so many theorems, because in class 10 and 11 we have the straight away the formulas P of A, P of A complement, or P of E1 union E2. Like you would have found the probability of union of two events or the intersection of two events. Or in the first two exercise of this class 12, you would have studied the conditional probability. Like already an event occurred, based on that, what will be the probability of the occurring event. Okay, you do have intersection in that. We have learned formula also. Okay, and now for the last and important exercise, we have theorems, total probability theorem and Bayes theorem. When we have to use the total probability theorem and what is it, and when we have to use the Bayes theorem and what is it. That is very important. And for probability, we know, like we are studying these probability theorems. How do we calculate the chances of an event happening? That is what the basic thing is, isn't it? So, what if we want to reverse the probabilities, find the likelihood of causes from the outcomes? Like from the COVID pandemic, we are all aware of the diseases that occur, and now also we have the seasonal changes and what all the diseases spreading because of the seasonal changes, and studying the root cause of it, and what will be the probability of that will be spreading to others or the blood result. So these kind of studying things comes under these two headings mainly. Okay, so first, total probability theorem. In that, this is mainly used to calculate the overall probability of an event when multiple causes exist. Okay, so for example, here I have taken a factory. For example, we have two machines. We do not have the idle machines, isn't it? 100% efficiency. So, though those two machines produce more items, we do have certain defective items. Okay, so machine 1 produces 70 percentage of items and we have defective rate is 5 percentage. Okay, and machine 2 produces 30 percentage of items and defective rate is 10 percentage. This is the statistics they have given in the question. Okay, now usually the probability questions will be what is from machine A, what is from machine B, what is the probability of selecting the machine 1. So you will be having the questions in that way. But here I have a question. What is the probability of picking a defective item? Okay. So now my question is, what is the probability of picking a defective item? So I have machine 1 that produces proper 70 percentage of proper items. Machine 2 produces 30 percentage of proper items. But I have certain percentage where I have defective. So I have defective items from machine 1 as well as from machine 2. Have they mentioned any like no machine 1 like it should be from machine 1? Is it like no from machine 2? Have they mentioned anything in the question? No. The question is to find the probability of a defective item. So it can be from the machine 1 or it can be from the machine 2. Okay. Now we have to assign three variables. That is, one is the item from the machine 1. One is from the 2, machine 2. And one is the defective item. Now the probability of items from the machine 1 that they have given as 70%. Either you can have it as 70 by 100 or the decimal, that's up to you. And for machine 2 it is 30% or you can have it as 30 by 100 or 0.3. This is the items that are produced by machine 1 and machine 2. Okay, and now defective item from machine 1. How will we know? Already machine 1 I know. I need to find already occurred event is machine 1. In that, what is the defective item? That will be given in the question 5%. So 5 by 100. So probability of an item being defective from machine 1. This is what we have learnt in the previous exercise. And now probability of an item being defective from machine 2, because we have two machines, machine 1 and 2. So the defective item can be from machine 1, can be from machine 2. They have not mentioned here. So I am finding the probabilities for both. As they have mentioned in the question as 10%. So here it is 10%, that is 10 by 100. Overall, I need the probability of defective item. Either it can be from the machine 1 or it can be from the machine 2. So for machine 1, I have the probability P of A1 into P of B slash A1 plus P of A2 into P of A slash A2, B slash A2. Okay. So substituting the values, you will find the answer. This is the total probability. If I have 4 events, then P of A3 into P of B slash A3 plus P of A4 into P of B slash A4. It continues for n number of events. It is not for only 2 events. It can be for 3, it can be for 4, it can be for 10, for anything. N number of items it holds. There is no condition applied. We are only finding the defective item. It can be from any machine. For this case, you will use the total probability theorem. So, when will we use the Bayes theorem? Okay. So, here I have mentioned, what if we reverse the problem? That means, my question was, what is the probability of picking a defective item? Okay. But now my question is, I know it is defective. Okay, I have taken an item or an object, whatever you take, that I know already it is defective. What if it is from the machine 1? What if it is from the machine 2? So that is what the Bayes theorem. So here, for the example, if an item is defective, which machine produced it? So there comes the Bayes theorem. The total probability is the overall probability. That means I need to know overall the defective items. So here I have used that one example. That's why I'm just keeping on using that. It can be for any other question. Okay. So total probability gives overall probability, that is overall defective items. Whereas Bayes theorem identifies the specific cause. As I have mentioned, I already know it is defective. What if it is from machine 1? So here specifically my probability is to find from machine 1 provided the item is defective. Okay, the item is defective. Here the general formula for Bayes theorem, they have used E1, E2. Instead of A1, E2, here you have E1 and E2. I already said in the question, here we have assumed that already defective one has B. Okay, here it is A. I know the item is defective, so it is already occurred event. What if it is from the machine 1? That is what we have to find. So you will find the total probability that will be in the denominator. Whatever the machine, that will be, that part alone will be in the numerator. Okay, so it will be like, no, whenever we have the ratios, a is to b is 2 is to 3, what will be the a's ratio? That will be like, no, for example, the ratios part and all we have studied, isn't it? A is to b is 2 is to 3. What is a share? Like that, we will take only the a's part. So 2x by the total parts, 5x into whatever the value you are going to find. For b share, what you will do? Whatever the b's part divided by the total. Similarly, whatever the machine is given, that part alone will be the numerator, and in denominator, the total probability will be there. Okay, so this is what the main difference between the total probability and the Bayes theorem. Total probability, when you use only when the event is a generalized one, to find the defective item, to find the ball is red, like, like whenever you have the generalized thing. Whenever the question involves, I know, like, no, it is already known the item is defective. What is from machine 1? So when the question is specific from a bag, like, no, we have bags of balls. What if it is from the second bag? What if it is from the third bag? So if that case, you will use the Bayes theorem. So Bayes theorem is also a part of the formula will be the part of the total probability. But we have as a fraction, numerator will use whatever the assigned value have or whatever it is given in the question. I hope this introduction part is clear. Okay. Moving on to the exercise. The first question. An urn contains 5 red and 5 black balls. A ball is drawn at random. Its color is noted and written to the urn. Moreover, 2 additional balls of the color drawn are put in the urn, and then a ball is drawn at random. What is the probability that second ball is red? So first, we have an urn. Okay. So exercise 13.3. An urn contains 5 red, 5 black balls. So I have red balls, black balls. Okay. Let us assume red balls to be E1. Let us assume black balls to be E2. Okay. And what is the total balls? 5 red ball and 5 black balls. The sample space will be 5 red balls and 5 black balls. What will be n of s? That is 10 balls. Okay. If I want to find the probability of red balls, then P of E1 will be red balls is 5. So this will be total is 10. The answer is 1 by 2. To find the probability of taking a black ball, then black ball I have 5 and the total is 10. That also 1 by 2. So initially I have red balls and the black balls. I have assumed E1 as the event that it can be the red ball, E2 as it can be the black ball. Initially I need to find the probability of finding the red ball and for black ball. So that part is over. Okay. Next, we need to select what is the main part of the question. A ball is drawn at the random. Okay. Its color is noted and returned to the urn. So it is returned to the urn. Moreover, 2 additional balls of the color drawn are put in the urn. Okay. And they didn't mention for which color. So it might be, so if I take red ball first. Okay. Then if red ball is taken, I'm going to put it back in the bag, and two more additional will be added, because moreover two additional balls of the color drawn are put in the urn. Okay. What is the probability that a second ball is red? So that is what we have to find. So let A be the event that ball drawn, second ball, yeah. So ball drawn in second draw is red. So how we have to write? Let E1 be the event of getting the red balls. Let E2 be the event of getting the black balls. Let A be the event of getting the ball drawn in the second draw as red. These are your three events. Okay. Now, I know, like, I have picked the ball. I know it is red. Okay. Now, I'm putting back to the second term I'm going to take. So when I'm going to return that ball to the urn, what I have to do? Two additional balls of the same color. What here we have taken? The red ball. So now, as I have already picked the ball and returned to the urn, returned in the urn. So now the total will also will be increased by 2, because two balls are added and two balls of the color. Here it is red. So n of E1 will also be added. So that is 7. Now to find the probability, how to take? I know it is already red. Now I'm going to find what is the second draw that is being read. Okay, that is 7 by 12. Okay, and now for the second event. So here, like, I'm taking the first chance and I'm identifying the ball color to be black. Okay, now again n of s, it's going to be added with 2, because I'm going to add two black balls. N of E2 will become 5 plus 2, 7 black balls and 5 red balls. Here I have 7 red balls and 5 black balls, and here I have 7 black and 5 red. Okay, this is what the case. Now what I have to find? I know the ball color is black, but what is A? Ball drawn in the second row is red, isn't it? So now ball drawn is red. Can I use 7 here? No, because it will be the probability of black. But here A is ball drawn in the second draw is red. So you have to choose the red part. That will be 5 by 12. Is that clear? This A is the ball drawn in red color. For the second event, for E2, we know the color of the ball is black. So I have added two more black balls. The number of black balls also will be increased. But now my probability already occurred event is black, but I need to know what will be the probability of the second one, that being red. Upon whatever the number is in the in that, what is the probability of being it is red? No, so it is 5. Now we found what is P of A slash E1, P of A slash E2, P of E1 and E2. What is the formula? What we need to find? Probability that the second ball is red. Second ball is red is A. What is the formula that we have learned? P of E1 into P of A slash E1 plus P of E2 into P of A slash E2. So P of E1 we found it as 1 by 2. This is 7 by 12. Then P of E2 it is 1 by 2. A slash E2 it's 5 by 12. So since I have 2 and 12 in the denominator, no, don't cancel it so that it will be easy for us to not to take the LCM. Here it is 7 by 24, 5 by 24. So 7 plus 5 is 12. 12 by 24 it is 1 by 2. This is the final answer for the question 1. Now is it clear? Second question. A bag contains 4 red ball and 4 black balls. Here we have only one urn. Here we have 2 bags. Okay, that is bag 1 and bag 2. So I have bag 1, bag 2. Okay. 4 red, 4 black. 4 red, 4 black. Another bag contains 2 red, 6 black balls. Okay. One of the 2 bags is selected. So from here itself the question starts. One of the 2 bags is selected. So from there itself the probability started because either I can choose bag 1 or bag 2. I should find what is the probability of choosing bag 1 and what is the probability of choosing the bag 2. As I'm involving the probability of bag 1 and bag 2, I am going to assign the event E1 as ball drawn from the bag 1. Let E2 be the ball drawn from the bag 2. This is initial points. We are framing it as the question. Okay. So totally how many bags are there? Sample spaces bag 1 and bag 2. So n of s is 2. Now I need to find the probability of selecting the bag 1. So it is 1. Correct? So P of E1 is 1 by 2. P of E2 is also is going to be 1 by 2. Like how we have head and tail in a coin when it was only one coin. Probability of head is 1, total is head and tail, so it is 1 by 2. Similarly, I have only 2 bags. I am going to choose either one. So it is total 2. My favorable is 1. So it is 1 by 2. Is that clear? So from there, we have to assume the events. So E1 will be the bag 1. E2 will be the bag 2. Okay. One of the 2 bags is selected at random and ball is drawn from bag which is found to be red. So what will be our A? That is the ball is red because a bag contains 4 red and 4 black, another bag contains 2 red and 6 black ball. One of the 2 bags is selected at random and a ball is drawn from the bag which is found to be red. Okay. Find the probability that ball is drawn from the first bag. As I already mentioned, whenever you have a specific question, Bayes theorem will be used because I know it is already red. What if it is from the first bag? Okay, because already bag 1 and bag 2 being the events and it is asked as one of the events. So it will be the Bayes theorem. Before that, we need to find P of A slash E1 and P of A slash E2. Okay. But the condition is the ball being the red. Okay. What will be the N of S in the bag 1? That is 4 red and 4 black. N of S will be 8. And what we need to find? A red ball. Yeah. So P of A slash E1 because I am choosing the bag 1. It is already occurred. And from that I am finding the probability whether that can be a red ball. That's why instead of P of E1, it's P of A slash E1 based on the question. I know already the event E1, that is bag 1. From bag 1, what is the probability that the ball is being read? How many red balls are there? 4. So it is 4 by n of s is 8. So it is 1 by 2. P of A slash E2. Similarly, P of A slash E2 will be, I know the bag is already the second bag. I should find the probability of getting the red ball. How many red balls are there? 2. N of S again here is also 8. So it is 2 by 8, that is 1 by 4. Okay. But what is my question? Find the probability that the ball drawn is drawn from the first bag and the ball is found to be red. Found to be red அப்படிங்கும்போது it is already occurred. For ball is red, we have assumed A. It is already occurred from the first bag. First bag is E1. Okay. What will be the formula? P of A slash E1 into P of E1 by the total probability. P of A slash E1 into P of E1 plus P of A slash E2 into P of E2. This will be your probability of finding the red ball that is already occurred, that is from the first bag. Okay. So P of A slash E1 is 1 by 2. P of E1 is 1 by 2. Divided by this already know, like 1 by 2 into 1 by 2. P of A slash E2 is 1 by 4 and that is 1 by 2. Okay. So numerator is 1 by 4 and denominator I have 1 by 4 plus 1 by 8. Take the LCM, simplify. Your final answer will be 2 by 3. Any doubt in this? Now the third question. Of the students in a college, it is known that 60 percentage reside in hostel and 40 percentage are day scholars. So 60 reside in hostel, 40 are day scholars in a college. Okay. So this will be our events. Previous results like no, we'll figure it out like how we have taken bag 1 and bag 2. In similar way, third one, we have hostel students and the day scholars. So what will be the E1? E1 be the student reside in hostel. E2 be the event that the student is a day scholar. Okay, this will be your events. And what is given? 60 percentage reside in hostel in a college. So P of E1 will be 60 percentage, that is 60 by 100. Either you have the 60 by 100 or 0.6 or whatever it is. And P of E2, 40 percentage are day scholars. So 40 percentage is your day scholars P of E2, 40 by 100. Time being, let us have it as the fraction without simplifying. Okay. Previous year results report that 30 percentage of all students who reside in hostel attain A grade and 20 percentage of day scholars attain A grade in their annual examination. So in both the cases, the common thing is attaining A grade. Okay. So let's have the target of, let A be the event of attaining the A grade. At the end of the year, one student is chosen at random from the college and he has an A grade. Like whatever we have assumed is not wrong. What is the probability that student is a hosteler? Already I know the student is A grade. So that means A is already occurred. What is the probability that the student is an hosteler? Hosteler, what even we have assumed? E1. So we need to find what is P of E1 slash A. Okay. Before that, they have given 30% of all the students who reside in hostel attain A grade. So I know it's E1 is already occurred. That is, I'm picking from the hostel. Okay, and attaining A grade only is my choice now. That is given as 30 percentage. So it is 30 by 100. Similarly, for day scholar, I need to find the A grade, that is P of A slash E2 is 20 percentage, that is 20 by 100. What we need to find? P of E1 slash A. So P of E1 slash A is equal to, what is the formula? P of A slash E1 into P of E1 divided by the total probability, that is P of A into P of E1 plus, sorry, A slash E1 into P of E1 plus P of A slash E2 into P of E2. So P of A slash E1 is 30 by 100. P of E1 is 60 by 100. Denominator this first part being the same. 30 by 100 into 60 by 100 plus P of A slash E2 is 20 by 100 into P of E2 is 40 by 100. As we have not cancelled the hundreds, the denominator is going to be the same. So I am getting 1800 by 10,000, the whole by, here again 1800 plus, since I have not cancelled the denominator, straight away we can add the numerators. So it will be 800 divided by 10,000. 10,000 gets cancelled. So here I have 1800 by 2600, that is 9 by 30. This will be your answer. Okay. Fourth question. In answering a question on a multiple choice test, a student either knows the answer or guesses. Okay. Either knows the answer or guesses. So now tell me, what will be E1, what will be E2? So knows the answer, we will have it as E1. Guesses the answer, we'll have it as P of E2. So question number 4. Knows the answer, guesses the answer. So this being E1, let E1 be the, even that student knows the answer, let E2 be the even that student guesses the answer. Okay. 3 by 4 be the probability that he knows the answer, and 1 by 4 be the probability that he guesses. So P of E1 will be already given in the question, P 3 by 4. P of E2 is 1 by 4. Assuming that a student who guesses the answer will be correct with the probability 1 by 4. Okay. What is the probability that the student knows the answer given that he answered it correctly? Okay. Now, let A be the event that student answers correctly. Okay. 1 by 4 is the probability that student guesses and the answer is correct. Okay. Answer is correct and the student is guessing it. Okay. And the answer is correct. So that is 1 by 4. For here, the student knows the answer and the answer is correct. So then that will be P of A slash E1 will be 1. Because for sure the student knows the answer and A is the correct answer. So both are like no, for sure it is happening. So it is 1. Okay. Now what we have to find, assuming that a student who guesses the answer will be correct with probability 1 by 4, what is the probability that student knows the answer given that he answered it correctly? Answers correctly is A, that is already occurred. What is the probability that student knows the answer? So I should find P of E1 slash A. That will be P of A slash E1 into P of E1 by P of A slash E1 into P of E1 plus P of A slash E2 into P of E2. Okay. Substituting the values, that it is 1 into 3 by 4 in the numerator, and here 1 into 3 by 4 plus 1 by 4 into 1 by 4. Simplifying the terms, you will get the answer as 12 by 30. Any doubt in this? In the next video, we will continue the remaining questions.